Hello. So today we are going to see how to use AWS Step Function with distributed map. This is going to be a hands-on session, so I will not spend much time. Just a minute I will spend to explain you the use case. Let's say you have a step function that processes a transaction using Lambda, and it processes a single transaction. And there is a case where you have to process multiple transactions as a data set, and that's where you use the uh, map state type, where it allows you to perform or the process multiple inputs with different data, different values in parallel. So there are two types of map state, inline map and distributed map. At high level, inline map is for smaller data sets, and distributed map is for larger data sets, where it also supports some additional features like from where to take those larger data sets. Okay, so the first step is to create a Lambda function. Create function, give your function name, process transaction, because it is going to process a single transaction. Uh, Runtime will be latest Python version, and create function. Okay, so the function is created. It is creating the default source code. So currently there is no source code for this function. So I will going to use the existing code that I have. I will provide a link to my GitHub repository where from where you can get the source code. Okay, so just to quickly understand this Lambda function, it is printing a loading function, and this is the actual Lambda definition that will handle the event. So what we are doing here is taking the event and the context, and we are creating the output that is based on the input data that is from the event. So what we are doing is concatenating the transaction ID, type, and amount from the event, and printing it, so that we can see this in our logs, CloudWatch logs, and we are returning that concatenated string back to the caller. So in this case, it will be a step function. Okay, so you can also test this function. So go to the test tab, click on create new event, just give any name, event one. So in this case, we want to process a single transaction, right? So we can provide input JSON from this inputs.json file. So just take the first part, which is a single transaction having transaction ID, type, and amount, and you can click on save this event, and then test. So if you see, the Lambda execution is successful, and it is printing the concatenated string where you have transaction ID, type, and amount. Okay, so our Lambda function is ready. Let's make sure it is deployed. Yeah, and we are good to go. The next step is to upload your dataset to S3 bucket, so that step function will use it. So I'm going to use existing S3 bucket. If you want, you can create a new one. So in this step function input bucket, I'm going to upload my dataset. Okay, so in the code, I have one file S3 object transaction dataset.csv, which contains the dataset. It's a CSV file where I have this comma separated list. First line is the name of columns, and there are three actual transactions. Normally there will be like thousands of transactions, but I don't want to like spin up a lot of underlying workflows. So I have kept only three transactions, and those three transactions will spin up three different step functions, and those transactions will be processed by those invocations. Okay, so let's upload this file. I can drag drop. Okay, so file is here. Click on upload. Okay, so the file is uploaded and your data set is ready. We are in the state functions service console. Click on create state machine. Since we are going to use the existing code for the state machine, I will click on blank and create a state machine. So go to the code section and let's reuse the code that we have. So in the code repository, there is a file step function process transactions distributed.json. So this contains the state machine code. So I will go through the code in a bit. So let's create the state machine, and it will create the role automatically that has all required permissions. So it looks at the code and based on that determines which IAM permissions are needed for the role. So let's create the role and state machine is created. So to take a look at the code, you see that the state machine starts at the process all state, and the set states section defines all the states. Basically, there is only one high level or the outer state called as process all, which is of type map. Um, so this item reader section defines how the input data set is read. So we are reading it from a CSV file. First row is the header row, and it is available in the S3 bucket at this path. The process item processor is a distributed map, and the state machine type is the express type. Now, in the processing, we are going to use the internal workflow. So, as I said, the distributed map invokes the additional workflow instances that will process each item separately. So that way, you don't see all the logs in the or in the outer state machine, but you see the individual state machine logs or the workflow logs in its own execution. So that way you can process, even if you process thousands of records, you can see the separate logs for each execution. So if you see in the item processor, there is a sub state machine, I would say. It starts at the lambda task state, and this lambda task state is a regular task type state, and it uses the lambda to do the transaction processing. So it's like regular stuff where we are specifying the lambda function name, the ARN. The payload will be the payload that we pass from the outer function. So every transaction payload will be sent to the each instance execution. Once that execution, lambda execution is complete, it will go to the next state, which is of type pass. That means it is complete, and since it's an end state, the execution will stop here. The result writer, where the execution results will be written to the same S3 bucket, but at this path. So you can use different S3 bucket, or you can use same, but for the simplicity, I'm using the same S3 bucket. Okay, so this is a code explanation, and we have a state machine ready. Okay, so let's start the state machine execution. In the S3 bucket, you see we have the CSV file that is our data set. So we'll go to the step functions. This is the step function that we just created. Click on it and click on start execution. So we are not providing any input here because the input will be taken from the CSV file in the S3 bucket. Click on start execution. So you will see that it started executing this outer step function, and it ran this map state where you can see the execution of each internal workflow separately. Right click on this and open in a new tab. So here you can see the overall execution is successful, and in the map run you will see there are three executions, three transactions in the data set. Okay, so you can click on each execution and you will see the input and output of that execution. So yeah, so that's how it processed all three records in parallel. Coming back to the outer state machine. Okay, now we can see the output in the S3 bucket. So in the S3 bucket, if you refresh, there will be a CSV process jobs folder created, because that is what we have defined in the state machine. CSV process jobs is the prefix for the S3 path. So go inside that folder, and there will be two files: the manifest.json that contains the information about the results. So let's download this succeeded underscore zero.json file. And if you open it, let's format it. Yeah, so here you can see all three executions, their ARN, what was the input, the output, and status, whether success or failed, and the start in time. So yeah, all the details will be available in the output file. Thanks for watching. If you like this video, please click on like button and subscribe to my channel. Thank you.